Good afternoon, ladies and gentlemen. My name is Carl-Ernst Forchert, and I will talk to you about an open and secure platform for in-car applications. I'm lucky to see that there are also some ladies here in the audience. I'm from automotive industry, and there it's a little bit old school still today. And so I'm very happy to see also some female experts here. What we are doing as eVector and I myself, we are doing some things in terms of innovation management, especially writing scenarios. And we did so 15 years ago, and that was the origin of the idea to do something with mobility and information technologies. What was the origin of the idea? One mega trend we found out was we will have some access and availability to mobility everywhere all around the world. That's not very interesting, but we found out it's not the vehicle, it's mobility itself. So that was mentioned by Wook. We have to change our mind from the car to access to mobility. We did this scenario analysis with many experts and in 7 fields of operation, from materials, from vehicle concepts, from manufacturing technologies, from production organization, mobility demands, and of course societal issues. And because of different societal issues, all the trends did not mix up in one central point. They are divided into different areas. And when you look at this land map, then you see trends which are close together. They are also in the graphic close together, and trends who are different in their content, they are located in different edges. So as engineers, we found out innovative materials go along with personal safety, that's okay. Also with convenience and comfort for the driver and the passengers. And on the other hand, the customer wants flexibility, and the flexibility is provided by the manufacturing system. At the very first trend, we discovered the X-tronic, the mechatronic, the electronic, IT trend of cars that was easy to understand. What we didn't understand at once was how do these both trends, mobility and information-driven society, go together. That's very obvious that these are the mega trends, but in 2003 we had no idea at that point. Information in a global society with local orientation, that was the trend, and we researched and we thought about how does it come together. In 2011, we made another scenario analysis with other experts from manufacturing and car development, and we considered car body, new propulsion systems, new materials, new planning processes, new business models. And there we find out some clusters of scenarios, and the first was very in common. We have evolutionary developed vehicles in conventional production systems, and there are also some subclusters, individualized cars and cars which look from the outer body all the same. They are only differentiated with end-of-line customization. Then we have totally different vehicles built in new structures of production systems with new powertrains, electric drive, hybrid drives, other trends. And we will come to that later. And these two areas are separated by river, and there are only few transferring scenarios leading us from today to these blue ones which are represented by the future. And in the end, we also have some third scenario that has something to do with textile manufacturing technologies and with generative manufacturing issues. That's very promising in case of 3D printing, 3D generating processing. But I want to focus on a very common scenario, which is very liked by the automotive engineers, because they said, we do not have to provide for each customer his own body shape. That was a trend the last 10 years. We have to provide for every market niche his own car. This is a totally opposite scenario. We produce the car in the same shape, and it's only differentiated by end-of-line customization. Like the iPhone. The iPhone comes up with 16, 32, and 64 gigabytes of memory. That's it, and it's individualized by the customer. And that was the beginning of the story, changing from the bodywork of a car to what is in the car. Another aspect is we have some different innovation cycles and usage cycles. We mentioned it already. A car is developed within a period of 7 years, and it's used by 10 years. And the electronics are in a very tight cycle, developed every 2 years, like phones every 18 months, for example. And if you buy a car, a new car, quite new used car, 4 years, it's from the electronic standards quite old. So how can we overcome this topic? So the mechanical car is quite new. Can we bring in some box which renews the electronic ability of a car? And that was the start of the idea. We have some helpers in the car, the anti-blocking system and driver assistance, parking assistant, till up to autonomous driving. That's in the scale of the car, the entire car manufacturer sector. No one can go into that part. On the other hand, we had at that time some infotainment issues, navigation systems, all this stuff. And the question was, is there some other room between? We had it before, 2 levels of applications, the infotainment applications and the really serious. And we already had some kind of these applications. It has something to do with customizing the car or with autonomous driving abilities or with safety things for the passenger, for example. Another safety thing is to recognize, is the driver able to car the right in a proper way when the responsibility will be handed over to the driver if the technique will have some problems. There will be some room of innovation, and that was the starting point. So we together thought about some applications. First one was a safety thing. We had one guy in our group. He's dealing with active safety. He deals with airbags. And the airbags ignites always at the same point when the crash is detected. And when a big guy sits behind the steering wheel, it's a totally different situation when a slim and small lady sits behind this steering wheel. So if you know the weight and the measures of the people sitting behind the steering wheel, then you can optimize the ignition time of this airbag. You can imagine it's an application which is very carefully, because it's safeguarded by the car manufacturer. Other applications are also thinkable. You go to the eastern neighbors, theft and vandalism of car is in common. If you have some applications, functions with GPS and with some automatic generated video and picture shooting, then you might grab the third-party guys. And other applications are available, but at that time we recognized we need some kind of data protection, for example, against abuse, against intrusion from third-party guys. This IT has to be reliability. And it has to be vehicle variable, because each car has its own CAN bus standard, and we have to go into these functions. And this interface has to be available for a certain time of usage period. We talked about some mirror link functions like before. You can see, you can use the keys of the steering wheel with some kind of application, but what to do if we want some more information from the car? We had a list of applications. In our group, we sorted out of about 50 applications. The first has something to do with safety, security, and health of the drivers. Another group of applications might be comfort applications, navigation, communication things. Efficiency of driving, going through urban areas with a lot of traffic jams, even for commercial users. Regulation, we mentioned the electronic logbook. Connectivity is a big area of application. Services for the car fleet provider. Oh, your car needs to have an update of firmware. You have to go back to the workshop, but can we do this over the air, for example? And one important thing is, of course, business integration. If you are a member of a fleet with craftsmen, servicemen going across the urban area, then you easily can integrate them with the help of traffic jam recognition and driving conditions and all these informations. And of course, we are looking for new markets, especially, for example, also in the cargo bike, 3- and 2-wheelers. We are not dedicated only to the 4-wheeler, to ordinary car. We also look at 3-wheelers and 2-wheelers, and especially here in Berlin, many cargo bikes are growing, and they also need some help by informations. Yeah, just some applications. We sorted them by customer needs, by business expectations. Is there business potential, like the predecessor told? E-logbook has some business expectations. And on the other hand, we sorted out the level of needed security. For example, if we dimension the ignition point of the airbag, then it's for sure the security level has something to do which treats the body itself, so it has to be life safe. So some other really safety and security requirements to the app. The mobility manager, the integration into other office functions, it has to be at least contract safe. Eco router, which helps you going easily through town, it's a comfort function. We also talked about pay-as-you-drive boxes, insurance companies. This has to be at least authorities safe, so to say. Connectivity things, Peter Conradi will talk about at that. It has also to be authorities safe. What does it mean, Cloud Atlas? Services, when there is an update to the brake system, it can be provided by a firmware update. Of course, it's life. It has to be life safe. It has to be follow the higher levels of ASIL level, at least 3. It's in the automotive language. The digital logbook, it's not that safe, but you can imagine that the tax offices has some requirements how to do this so that it can't be manipulated by individuals. And so we clustered and collected some kind of these ideas, and therefore we created a list of tables. Which kind of technical requirements do we need to provide some kind of these applications? We need some kind of telematics. We need some kind of interfaces, USB, near-field communication, all this stuff. CAN bus access, it's an important thing. We discussed it already. And also with some kind of, what kind of computing capacity and big data processing has to be needed in the box or in the environment of this thing. We collected them and we listed that, and that was the starting point of our consortium of 7 different project partners here in Berlin. And we are now in the stage of developing this kind of box. The box, it's a box which collects the data from the CAN bus, which collects the data from other sensors. The box maybe itself has some sensors, at least the GPS sensors, and will have some access to other HMI devices in the car, your smartphone and whatever you want, Wi-Fi and all this. This box has the ability to compute for itself the signals, is able to buffer some signals, because if we are in some areas where the 3G or 2G connection is not available, we need some buffers for secure transferring the data. And of course, in the back end, we need some server infrastructure where we collect the data and provide them for different business applications. The service provider, the mobility provider, app developers, and other community members are part of that. Which is in common of all of these 3 items? We need some IT, security, safety level for safe operation of these mobility-oriented applications. But first, I want to hand over to Peter. He's one part of the member. He's member of the Steinbeis Institute of Electromobility and Information. And he got an idea in our consortium, and he will explain us.
Thank you, Carl-Ernst. Yes, thank you for the chance talking a little bit to you. Until now, the talk was concerning more this market aspect or this technology, this big technology view. But I know that you are a community of people concentrating on one operation system, on a kind of smartphone. So my task will be coming closer to you, not too close, and I'm going down here. Coming closer to you and try to get you a little bit involved into our ideas. So I'm presenting the second part here, and I'm talking more or less about the art of programming Android customer devices, and doing this in an automotive environment. That's my job for today. And as you see here, as you see in the streets, the cars are changing. The cars are getting more modern. We have hundreds of ECUs, or in other words, of small computers in a car. And cars are having more and more electronics. And we are living in a technical environment which is really amazing for technical freaks, but it's a big change. And we in Germany have the position that we have this market of kind of intelligent cars worldwide. So if you're going to other countries in the world, you see this this German car thinking there. So we in Germany, we have this electronics, we have this the capability of a high sophisticated and high derived car technology. But how about the connection to our private mobile devices? And so a few days before, when I started preparation of this talk, I looked to Android Auto. And I thought about, we are here in Germany, the most famous car builder in the world, but we are not having Android Auto yet. So what is the situation in this market? And then I tried to concentrate a little bit of what is happening in the scene between this modern luxus cars, what we are producing, where we find in Germany, Mercedes, BMW, Volkswagen, and the possibility of using smartphones there. This is my belief is that the integration of smartphone technology in the cars, it's quite complicated. And I will tell you why. We have this both worldwide operating smartphone types or smartphone vendors, Apple and the Android world, were offering car-related APIs. That's I'm talking today. So if you are getting back in a role of a typical Android programmer, then you have in your environment, in your SDK, in your IDE, you have this smartphone as a destination device, and you are developing on a PC or wherever, developing your smartphone software, believes that you are using Android 5 for this. That's the basic position, what you're currently doing. How you can connect your software with the car? How we can do this? The answer could be that that Android gets a new API, deploys a new API called Android Auto, not available in Germany, as I said, and so on. And then you have this library. You can include it, but it's useless because if you are compiling something in your Android environment and you have no car, then you cannot use this Android Auto API. So you need a car. And if you have a car, and this car is supporting Android Auto, as many cars today are doing, except in Germany, but it's coming soon, I believe, then you have more or less 3 things in the car. You have a microphone. That's not the microphone of your smartphone. It's a kind of car microphone, wherever this is. You have some very small switches in your steering wheel. That's clear, because nobody wants you to touch your smartphone while driving. And you have a monitor. This is part of a car somewhere. It's a small monitor, and this API gives you the possibility to connect over USB to this car somehow. And your libraries are enabling you this kind of working. And we are speaking later about what you are programming. Primarily is or more or less, I want to speak about the system before we are going into what can we do with this environment. But this, what you see here, this is set by the provider Android for using libraries, building car apps. And afterwards, the app is not running in your smartphone. It's running in the smartphone maybe, but it's also mirrored or processed in the car, in the HMI, and displayed probably in the HMI monitor itself. That's clear. That's a similar technology, I believe, as we have with MirrorLink or other technologies, very famous in last time. But what do you want to do there? if you want to program a navigator, it's no problem. Your smartphone has GPS, and then you can build your routing and you're ready. You don't need anything out of the car. But as I told you, or as we discussed before, the car itself has hundreds of processors in the car. Why losing this intelligence? Why can we not connect this to the CAN bus, for example, or to other buses? Let me paint this here. Okay, now you see a CAN, but how to connect to the CAN? And if we are working on CAN bus technologies, then we see that even different series of cars of the same developer have different CAN IDs. So nobody can make a reliable development of information coming out of the car if we don't have a standard coming over to say this CAN bus ID means always the odometer or whatever. And we don't have this. So Android Auto in this case cannot really give you an access to the inner electronics. Or could or could not. What will happen? Android Auto is working with, let's say, 20 OEMs, so developers or producers of cars worldwide, but will they give you an access to the CAN bus? Yes or not? No? Who says yes?
Nope.
Nobody. Okay, so not. But in this case, we are losing this kind of mega computing with hundreds of ECUs in the car. Whatever they are doing, we cannot use it. So we are lost in space a little bit. And what we did in our consortium, it's we are working within 2 or 3 years on this idea and getting more and more involved into this technology. We defined a kind of new computer, and it looks like a black box. It looks like one of the ECUs in the car, looks the same, but has another task, has another work to do. It's not the work of getting something to do in the car for braking or ever. It's more to use this telematic task to transfer information from the car to the internet. And my idea is to let such a box communicate with a smartphone and develop a kind of CAN API. Let pure Linux run on this device and giving the community the chance of transferring information from the CAN bus to a maybe self-developed Linux system on board, in combination with communication to an internet server. That's what this picture tries to express. This is complicated because if you write some information to the CAN bus, then it could happen that your car is is processing fail functions and running against the wall or whatever could happen. It's in any case, it's very dangerous to communicate with this complicated inner electronic system. So we need something like big effort on the safety side, on the security, not safety, on security, because safety is more or less a real damage prevention. Security is what we need to prevent our system that it's doing something wrong on the canvas side. That's what we are doing. Currently, we cannot give you too much details on this because security always needs very much time, needs a big, deeper knowledge of the lower ISO-OSI levels and so on. But we can use today, our project is, let's say, running another year. And during this year, we try to finalize this architecture to find, let's say, a good community communication with people working on the smartphone side. So that's why we are here. That's what we have in mind. To starting today, the discussion with the Android community to ask, what are your needs? What do you want from the car? How we can help you? Do you want to write native software on a Linux app there? And let this app communicate with your app in the smartphone? Is this what you need? Do you want to access the CAN bus? What kind of information do you need from the CAN bus? Do you need only the speed? You can calculate the speed yourself with your GPS receiver. What do you need? And where is this going to? In which point, and Carl-Ernst has this timeline there. What is happening in 5 years? What is happening with these hundreds of ECUs in the car, which are working isolated from our smartphone? And can we have such a kind of mediator, like a Linux system in between, helping us to cross over? These are our current questions. And we are currently developing a few programs, a few apps on the box and on Android to show that our system is running. And afterwards, we are ready to go into the community and going to the B2C market or the B2B market to let the community come closer to our idea.
Okay.
This is a list of apps which are under thought at the moment, which we can give to the market if we are using our system in a kind of cooperation. And let me come to a short conclusion. The last point is most important. So we are planning the availability of this Linux box for automotive purposes with an E1 Zulassung for the middle of 2016, at the least of the end of 2016. And we will try to realize a kind of proxy function, going with your smartphone to our box and from the box to the internet if you want to do so. And we have this CAN-DB, where you can, dependent on the car model where you're working on, you can get some help from us and so on. Okay, at this point, I will hand over to Carl-Ernst again. And
who are we? It's a consortium of mainly Berlin, Brandenburg partners. Peter is coming from Darmstadt. Starting point was Adomite Julius. He's doing the airbag issues. MBDS is doing programming embedded system. And a real important part plays the Freie Universität in Berlin. Volker Roth, he is the professor for secure identity. That's a big issue. I don't want to go deeply, but it's obvious that we need some information security in both directions, not to harm the car, but also not to harm the user, because the user is driving, producing lots of data. What will be done with the data? Do we allow Google or other communities to use the data? That's a big question. And other companies, and Steinbach, we already mentioned. And why we're here? We are here to ask the community. It's the first time for our project committee to go outward, to invite you to test the system, to invite you to exchange ideas. Maybe you have some ideas you want to bring in and demonstrate some issues. We, as 8 people, we gathered 50 ideas of applications. So you might also have some ideas, and to provide a playground for testing, demonstration of these kind of ideas, and maybe in the end providing solutions where you can make some business, and that's all a part of a slightly change of the usage of mobility. I mentioned before, another scenario is left. It's called the Samsung car scenario. It's not because of the company Samsung, it's just the answer of the question, what might happen if a big electronic company, enterprise, goes into the mobility business and senses a lot of business. How will they do that? The scenario comes from the computer. It's generated by algorithms, and workshop experts from Volkswagen and from KUKA and from other German companies interpreted it, and that was the result. So the car is just a carrier of new information and communication functions with lots of assistant function till the autopilot function, of course. Lots of mechanical stuff I want to skip. And sustainability of the car is important, and this car is developed in a very short time and with a drastic reduction of the time to market to avoid misunderstandings how the market goes. And that's some similarity to the telecommunication market, where mobile phones, smartphones are in very, very short cycles produced, developed for the market. And we can imagine that this type of car has totally different quality requirements, issues, than an Audi A6 or some typical German car. This car has new functions in new information and communication things, and that's your future. And that was derived 4 years ago. Today we know Google and Apple is doing some business in this case. It comes true, and that's our field of business. Yes, thank you for your attention.